the next frontier in healthcare, a BPM Plus Health virtual event that we organized this week with sessions and demos from the HIMSS conference. My name is Tracy Berardi, Program Manager of BPM Plus Health. So this is our first session of the two-day virtual event, Veteran Care Without Boundaries, Implementing BPM Plus Models as Software is the name of this session. And speakers on the line include Ken Rubin with the Department of Veterans Affairs and Community Convener of BPM Plus Health, Bo Dagnall and Shane McNamee from Perspecta, and Ken Lloyd from MDIX. There's a link in the chat box, in the GoToWebinar toolbar in the chat box, a link to a page on our website where you can find the schedule of events over the next 2 days. This is also where we will post the recordings from the presentations for future reference later this week. If you have questions during the presentation, you can enter those in the questions box. If we can address them towards the end, we will. If not, we'll take it offline and email responses back to you. So I'm going to turn this over to Ken Rubin to get started. Ken, over to you.
Yeah, good afternoon, everybody. Good morning to the rest of you. I just wanted to take a moment before we jump right into the first session to provide a little bit of context. BPM Plus is a community of practice that launched last September in Nashville. It's operating under the auspices of the Object Management Group, which is a 501c6 not-for-profit industry consortium. And really, it's providing a place for us to look at how to foster and advance shareable workflows and shareable pathways using open industry-based standards. So what we'll be hearing over today and tomorrow are a set of case studies that were, again, intended for the HIMSS conference. And then we applaud HIMSS for making that very difficult decision, but certainly we're disappointed. That said, we're thrilled to be able to bring that content to you through this forum. So over the course of this 2 days, we've got better than a half a dozen sessions, all exploring different aspects of this concept around workflow portability and shareability based on open standards. You'll be getting different perspectives and different case studies from different parts of the industry, some vendors, some providers, and so on, professional societies, each interacting with this content in perhaps different ways, but showing the value, viability, and importance of advancing this as a standards approach and this community of practice. Those that are interested in BPM Plus, we encourage you to visit the website at bpm-plus.org. That'll be it for the plugs. What I'd like to do without further ado is turn the baton over to our first set of speakers. So without any further delay, I'll pass it to Shane McNamee and Bo Dagnall.
Greetings, everyone. Shane here from Perspecta, Chief Medical Information Officer for the Health Business Group here at Perspecta, longtime VA clinician before this. Bo, you want to say hello quick so they can hear your voice too?
Yeah, thank you. This is Bo Dagnall. I'm a CTO with Perspecta. I've been working in and around the VA for many, many years. And we also have Ken Lloyd as a speaker.
So really appreciate everybody's time here today. We were very, very excited to show off this demonstration, really the art of the possible for standards-based automation of clinical practice guidelines at HIMSS. This work has been several years in the making through the BPM Plus Health community, and we're really excited to show it off here today. I do want to focus really quickly on the bottom of the screen there, your eyes, on our vignette partners. We had a tremendous a group who were supporting the vignette at HIMSS. I'm just going to read those off. It's our partners at Red Hat, MDIX, Teresa Tech, Microsoft, Book-Zerman, Metal Algorithm Company, and obviously our group here at Perspecta and the BPM Plus Health community at large. So tremendous amount of support from them and a lot of movement in the industry towards what we believe is this next great standard in healthcare. Next slide, please, Bo. We're going to show you here today how we can take standards, specifically the BPM Plus Health, the CDS hooks, and the FHIR standard, and automate clinical practice guidelines. So specifically, the VA DoD clinical practice guideline for chronic kidney disease is what we'll be focusing on here. We'll be taking you through a patient's journey and showing you how these best practices can actually be implemented into workflow, both from a population health perspective as well as from a patient-specific perspective. Next slide, Bill. So the problem is care with boundaries right now. It's the way we like to think about it. We have a very parochial health IT system and a very parochial health information and a healthcare system in general, where we as patients do not flow across the boundaries of healthcare all that terribly well. There are a litany of IT boundaries, and this makes everything too expensive and unreliable and excessive or inaccessible and efficient and unsatisfying. And we find that this is built into the system oftentimes by legacy health IT providers who provide proprietary data models and try to really lock our data and our processes into specifics. Why is this no longer relevant, or why can't we go in this direction any longer? If you look at that graphic in the upper right-hand part of the screen there, you know, which one of these things is not like the other thing? In the United States, we are really triple the cost of living increases in terms of healthcare costs over the last about 30 years. By 2027, if unchecked, it'll be about 20% of our GDP. We cannot sustain this anymore. Even more so, the fact that it still takes 17 years to get best practices into healthcare workflows. And, you know, a variety of other things, including the doubling of medical knowledge, you know, every 73 days at this point, makes it very, very difficult for clinical providers who want to be able to provide the best for their patients and the best resources for their patients and knowledge. So really difficult to access that and to put that into place in busy clinical schedules. Next slide, Bo. So chronic kidney disease. We chose to focus on chronic kidney disease, number one, because of the VA DoD clinical practice guideline that's there, but also for the fact that chronic kidney disease is one of these things that's really bad. It's 33% of the fixed budget for Medicare, but 9 in 10 patients don't know they have it. It's really easy to prevent kidney death, but once it happens, the impact is massive on the patients themselves in terms of dialysis, lost time from work, and everything else that happens. And these things can be prevented if we can find high-risk populations early on. And, you know, simple things like a $20 diabetes education annual subscription or $100 of IV fluids or hypertension treatment can really stem the significant impacts of chronic kidney disease. But unfortunately, we don't know it until it's too late. So, you know, really, if we're looking to bend the cost curve on things, and by cost, I mean both overall financial costs, but human suffering, it's about identifying things early on or risks early on before the planes have crashed, so we can help, you know, people get healthy and avoid all the madness that comes with chronic diseases. Next, please. So this is the VA DoD clinical practice guidelines for chronic kidney disease. This is the pocket card itself. It is a field-leading piece of information on identifying and mitigating CKD risks. It's extremely effective when followed, you know, both for costs and, you know, decreasing human suffering. The problem is with most clinical practice guidelines and best practice guidelines is they exist on paper. The one that you see on the right and that algorithm in the second box sits in front of about a 250-page chronic kidney disease full algorithm and document that you know, we most generally print off or send off in PowerPoints and try to disperse across healthcare. But you know, busy clinical providers don't have the opportunity to pull all of these numerous different things out, map where their patients are at over time, consider all the different factors, and really need to start to move these things into workflow so we can make healthcare both a higher quality, but also significantly, hopefully, more efficient. Next, please. So care with boundaries. All these things are scattered across healthcare, right? As if you are a healthcare provider, you likely log on to 3 to 7 EHR applications every day. You're using the internet. You're using these pocket cards. You're using books in lots of different places. You're getting data from a ton of different sources. There's a ton of different knowledge, calculators and decision support and algorithms, lots of different processes and insights, but they're not bound together. Number one, around the patient who needs them and to have contextual information, but also for guidance for providers in terms of, how do we keep patients on the best glide path with chronic health conditions, in giving them the treatments and the impacts is most effectively for them over time. Next slide, please. So solution, there's a group of us, a large group of us for the BPM Plus Health community and other places that are driving towards a public health utility to help rationalize our health IT ecosystem. This is driven by standards, everything built on standards from bottom up. That means using FHIR, BPM Plus Health, CDS hooks, CQL, and other standards that exist out there to move away from the legacy proprietary models that lock us, either our data into hospitals or into EHRs, and really to give us a better pathway across our own personal healthcare journey. So what you're going to see here today is what we call the CKD-E pocket card. So we've taken that chronic kidney disease model and we've re-represented it into machine run model through BPM using both CDS hooks and FHIR to integrate knowledge, to integrate it into workflow, to, as I said earlier, identify high-risk patients from cohorts early and intervene before the damage occurs. Next slide, though. So this is the movement from, on the left, you'll see the pocket card, and this is what rolls off in terms of best practices on paper, generally speaking. And on the right is the picture of the executable BPM Plus model that we built using FHIR and CDS hook automation. Bo, you want to grab from here?
Sounds good. Thanks, Shane. Yeah, so what Shane has described here is a model for how to treat a patient with chronic kidney disease. If you were to zoom into this and study, you'd see there's a number of activities, a number of steps that a human or a system can do along this journey. There are decision points and branch points. There are decisions that can be made along the way. There's various data that needs to be considered. All these objects on the bottom of the diagram represent different data points that might be embedded inside the patient's medical chart that you need to consider along the way. To be able to follow this requires a human, today anyway, to go through and understand the process, know what data is needed where, assemble that data across a variety of systems that they use, keep it all in their mind, process it in such a way that helps them make decisions, and then walk through these steps. What we're going to show you today is a software solution for automating a lot of what is done by a human today. So with that, I'm going to switch over to a live demo. So I'm going to show you a user interface. This is a web-based user interface that sits on top of our Health Concours platform. Health Concours is middleware. It tries to solve the problem of getting all the data into a useful standardized format based on FHIR, making that data computable so you can run algorithms against it through standards like CDS hooks and the clinical quality language, and then using that information to drive automation through BPM Plus models. The UI itself is just a view on top of that. So what I'm showing you here is a web-based UI where I can pick a patient. I've got some test patients loaded. May Jackson is my patient of interest today. And this UI is now hitting the APIs that give you access to all the information. Health Concours will have already gotten the data from different systems. It could be an EMR system or a data warehouse or a health information system or whatever it may be. pull it all together, standardize it, and make it available through APIs. What you're seeing here is the result of those API calls. So the first screen is just sort of that cover sheet. More interesting than that, I think, is the metadata tab, which gives you a profile of the data for this particular patient for May. Now, because we're doing this based on FHIR, all the data is organized as FHIR resources. These are the FHIR resources that make up this particular patient's medical history, and how many of them we were able to assemble, and from how many sources. So in this case, we have 22 medical conditions for May from 2 different sources, and 56 observations from 2 sources, and so on and so forth. You sort of get a footprint of the patient's data with this view. Any of these can be drilled into. We can go and look at the patient's problem list, for instance. Here's all the different problems this patient has. You can see some of them came from, in this case, the Boise General Hospital. Some of the data came out of the Vista instance at the VA running in Spokane. Of course, these are not real systems. For demonstration, these are all test systems, but it gives you a sense of what it would look like. Each one of these being a FHIR record, you can see the underlying FHIR structure behind this if you want to. The data did not come to us as FHIR. Each system gave it to us in whatever format they were built to work with. Could be proprietary streams, could be database queries, could be HL7 version 2 messaging, whatever the case may be. We took the data as it was, mapped and transformed that into FHIR, so we could then compute against that data based on its standardized representation. One of the things we like to do with that then is to drive the automation behind a clinical practice guideline described as a BPM Plus model. But to show you that, we have a care pathways capability. When we have 2 different care pathways currently running, one for diabetes and one for chronic kidney disease. I'm going to go ahead and launch the model for chronic kidney disease. And this is now interrogating the BPM Plus model itself to learn about what activities are described within that model and what information needs to be provided to be able to supply and automate the steps described by that model. So here's a view of that model. This is the same set of activities that you saw on the previous diagram for the CKD e-pocket guard. It's just drawn slightly differently to show how to show it on a screen. And the first step here is, does the patient have an urgent or emergent condition? Now, if you were to go and study the actual model, you'll see this step requires a handful of different data points to be able to consider, and there's a calculation and algorithm behind it that lets you determine whether or not the answer to this question is yes or no. We were able to automate that. We can discover at runtime what data is needed, and we can bind to a knowledge service or an expression of an algorithm that can be run as behind the scenes to calculate and automate this particular question. So in this case, you're seeing on the bottom the fact that we did find that this patient has what might be considered an acute or urgent or emergent condition. However, it's marked as inactive, right? So based on that information, if I click next, we'll see that it's going to go through this decision node and it's going to go down the no path, right? The yes path would say go to the ER department. In this case, it did not meet the criteria for that. So clicking next will automate that decision. It's working with the model again, and we'll go to the next step. In this case, let's go to the step that says, does the patient have evidence of CKD? So now we're evaluating whether or not this patient should be treated with a CKD protocol. And it came back with the answer. Again, we can automate that because we understood the data required, we understood the step it was taking, we understood the decisions and the algorithms that could automate that particular piece of information. So we provide clinical decision support behind the scenes. And here's the result. We found evidence of chronic kidney disease. And we used various observations in this case to come to that conclusion. So it gives you some view as to sort of the outcome and the evidence behind it. Clicking next will allow the algorithm to go to the next step. It's going to evaluate whether or not we should go down the yes or the no path in this case. And because there was evidence of CKD, it went down the yes path. Right. So the next step in the process is to determine the stage of CKD. How severe is this patient's chronic kidney disease? Again, that's a decision that can be automated with a clinical decision support algorithm running behind the scenes. In this case, we were able to determine that this patient has stage 3 chronic kidney disease. There was, again, an algorithm behind it. It came to that conclusion, and it came to that conclusion based on a variety of data points, right? Based on some demographics, based on the fact that they have kidney disease indicated in their medical history, some lab results, some procedures that were done. It considered all those against the algorithm for determining what the staging level should be. So we'll click next on this again. This will go to the next step in the model, which is to determine whether or not, once it refreshes, we need to have a consultation to a nephrologist. Is it significant enough that we need to refer out? And it turns out in this case, the data that was supplied by the patient's chart behind the scenes was not sufficient to automate the execution of the algorithm. The system was smart enough to say, okay, maybe it needs 10 data points. I only have 9 of those 10 data points. I need to capture that 10th point to be able to move on. And that's what it did here. It's saying there's additional data required. So we have that feedback loop that says, where I don't have the information, let the user, the clinician, provide it for me. In this case, it's simply missing status of this metabolic renal disease, and it populates the drop-down list of options. This again is based on what the FHIR expression for this data should be. It tells you what the value should be, right? So we can pick the one that's appropriate. Click next. Now behind the scenes, this is adding that information back into the medical chart for this patient. So the next time you come through this, you won't be asked a second time. And then it's considering that information as part of its calculations, and it came back with an answer. All right, in this case, it says, yes, we do recommend that you refer to a nephrologist. There's 5 indications that suggest that, and here's some of the data that was considered as the evidence basis for that decision. So I can go ahead and click next on this step, move ahead, and I'll see it's gone down the path for the yes route, which is to consult to a nephrologist. Now, when we set this up for HIMSS, we had one of our partners, Book Zerman, has an application called CareNexus. And this is where we would have launched CareNexus, and that would have been used to play the role of a nephrologist who is using that application to do their part of the treatment protocol, including the administration of medications and pain management. For today's demo, in the interest of time, we did not include that piece of it, but for the full experience we were producing at HIMSS, that would have been the next logical step. Okay, so sort of in summary, we were able to pull together data for the patient from a variety of sources in different formats, transform that into FHIR and make it computable so that we could just drive clinical decision support algorithms behind the scenes, as well as automate the flow and the steps within a business process model. The underlying architecture for this platform is described by this diagram, which is quite busy, and in the interest of time, I won't get through all of it, but I will call out a few key things. Think of it as 4 big pillars of functionality. First is data ingestion and standardization. We're able to pull data from different sources. We had a Vista databases, Cerner databases sitting behind the scenes, each of them having a portion of the patient's record. We're able to standardize that into FHIR. We're able to use that data to evaluate various knowledge artifacts. We have partners like Motive and Metal and Dynamic Content Group and Microsoft who are knowledge engineers. They have that expertise. They can define algorithms like staging algorithms for calculating someone's stage for chronic kidney disease as an algorithm, deliver it through clinical decision support standards like CDS hooks and CQL, so we can evaluate the data against that. The next step was to automate business processes. So we took that CKD model that you saw before, made it runnable with software, discovered where the data was needed, what decisions were needed to run it, and we're able to walk through the steps behind the scenes, remove the cognitive burden on the human to be able to do all that for themselves. And then lastly, sort of the syndication layer. How do we make this available for applications to then use? What APIs, what exchange mechanisms are supported so that people can consume this information, and the applications on the front end that show you that user experience. In this case, we showed you today the patient viewer. So that was the demo. And with that, I'd like to hand off to Ken Lloyd from MDIX. He's going to talk about how we actually took the model that was a platform independent model and made it run as software within this platform. So over to you, Ken.
Thanks, Bo. Next slide. So my name is Ken Lloyd from MDIX. MDIX is a founding member of the BPM Plus community, and we're committed, as I think everybody in the community, to implementing and leveraging open standards, and in our case, both from HL7 and from OMG. And I think the other part of what's important in the community, as Bo described on a couple occasions, is the automation and the ability to bring these things to market faster so that they can be used. So on this slide, let me talk a little bit about what MDIX does. And so on the upper left-hand corner, we've talked about the BPMN Plus models and how that then gets a little bit refactored into the demonstration that Bo just showed. And that these BPMN Plus models are platform independent models. They are shareable, reusable, customizable, and extensible. but they also instantiate best practices. And in this case, the PIM that we're using for this demonstration is the CKD model. In the bottom right is, as Bo just described, is the Health Concours, is a platform-specific model or a PISM. And this happens to be Health Concours. Health Concours can be used in many different ways, and one of them is as a platform to execute BPM plus models. To be clear though, some organizations have invested millions to billions in dollars in their PISM, and they just can't replace those things overnight. So just as there will be multiple BPM plus PISMs, there are also going to be multiple healthcare PIMs, or vice versa. So that our role and MDIX's role is sort of in that position to, we're in the operationalization of connecting PIMs to a PISM in order to have a working application, so that we play a role, as Bo was describing, of taking that independent model and making it executable within a platform-specific model. And we see sort of this operationalization as two distinct functions. And the first is to automate the implementation of the PIM into the PISM. And for this example, again, we've used the CKD model and Health Concours and their services, such as the orchestration services and process and knowledge services, terminologies, and others. And we believe that automation, and by automating some of this, and we'll talk a little bit that on the next slide, will, by having the goal of automation and using automation, we can reduce that 17 years that Shane mentioned earlier to provide a best practice in a much more decreased time period, as well as not only that, but it should provide benefits to quality of care at point of service. So automating the implementation. The second part of operationalization, though, and the second functionality is the automation of process improvement. You know, we've heard that knowledge in healthcare doubles every 75 days. How do we incorporate this new knowledge into a working system? How do we get to the point where we can take the evidence of our existing clinical pathway operation, improve it, and then actually change the system? So, combining a standards-based, model-driven approach for operationalization sort of enables, and I'll talk a little bit about that, how again, enables the automation of process improvement. And again, process improvement, this can reduce the resources necessary to implement a new version. Change management costs sometimes represent 70% of application lifecycle costs, cutting into that cost barrier and still being able to improve the ability of quality of patient outcomes. So next slide, Bo, please. So on this slide, let me go a little bit, and not in great detail, about the view of this operationalization as it deals with data objects. And the data objects here are represented in that PIM by the icons in green, orange, and white. So to achieve this operationalization, we worked with Trizatec and their tooling that was used to create the CKD model and annotated the model with logical business concepts that are recognizable to subject matter experts. An example of this might be they need to know what the patient's cell phone is. And these annotations are then included at the logical level in the CKD computable file. In the PISM, using automation techniques, we created Health Concours PISM files that also link to a logical business objects in the health services, Health Concours services. And an example of one type of service might be one of their fire endpoint services. And finally, as part of this operationalization, is leveraging the Health Concours services, in this case, the CKD application, can dynamically discover and execute the appropriate functionality to move data between services. So at this high level, this sort of describes the automation of the implementation by decomposing the problem into, making integration between the PIM, the PISM, and the existing infrastructure of the PISM. It also, though, supports the process of process improvement. It allows for the capability of plug and play. This approach enables the isolation of change and makes change simpler. As I said, there are 3 different files. There's the CKD computable file, there's the Health Concours PISM, and there's the runtime configuration files. Change is isolated into one of these 3 components, and change now becomes a configuration issue by changing a file, and it's not a development issue. Next slide, please. So the previous slide was about data and semantics and the capabilities what we're trying to demonstrate. It is important to note that in this case, the ability to achieve plug and play is not only from a data level, but it's a services level, and to be able to plug and play knowledge services or other services that enhance the process or have been improved in part of the process. And this requires the leveraging of dynamic discovery of the appropriate service, which includes things like registration services and microservices infrastructure provided by Health Concours. So that's my presentation of, sort of what we're trying to do and a little bit of peeling back the onion of how we make that done. So I'd like to turn back the presentation now to Shane.
Actually, this is Bo. I'll go ahead and jump in. So,
okay, thanks.
All right, thanks. So we'd like to close with this slide. This shows you a collection of companies who have been working together in this problem space, understanding that no one technology, no one company can and should solve this problem in its entirety. It's an evolving, dynamic, large, complex problem, and different technology companies each offer pieces of the puzzle. That's been the case forever. Organizations like the VA have no shortage of technology. They have one of everything. It's not a problem of having the right technology. It's a problem of cohesion. The problem of how do you pull it all together? How do you leverage the various technologies from different companies in a way that collectively solves this business problem? And this is an example with our Health Concours platform as the underpinning of where we were able to leverage technologies from a variety of different companies and provide that cohesion through standards-based interfaces by using FHIR as the expression of data so that everybody had a predictable, consistent, and computable way to understand what the patient's records are, by using CDS hooks and CQL to represent knowledge and execute knowledge algorithms dynamically, and to use BPM Plus for health to represent workflow and clinical practice guidelines so we can automate that. All these pieces were able to come together. And it really truly takes all these different groups to do it. And just want to have a shout out to all the partners who participated across this ecosystem. And Shane, any closing thoughts from you?
Yeah, just next slide if you don't mind as well. We got into healthcare as clinical providers because we want to help patients. It's an earnest group of people. Over the last decade, we've been turned into information mules. It feels like we work for computers and EHR systems rather than the other way around. The time has come for a change. The time has come to really build orchestration models that sit in the background, that can drop best practices in, that can bring clinical decision support up, so we can begin to automate the numerous or innumerable number of menial IT tasks that we perform on a daily basis. And we need that time back. We need that time back to spend time with our patients, to help them with health promotion. We need that time back to get home to our kids, to their soccer games, and not being, slaves to the computer. This BPM Plus Health initiative really offers truly a future of care without boundaries that flows our care for us with best practices wherever we go, and can really help begin to make healthcare more affordable, more efficient, feel better, and more effective for everyone. This is the future, we believe. And for those of you who are interested in this and believe in standards-based automation across healthcare, take your time, follow our friend Ken Rubin here, who's been pulling us forward in this for years. Join the BPM Plus Health community and be part of this wave that is going to really shift the art of the possible in healthcare. So really appreciate your time and happy to take any questions.
Hey, Shane, Bo, Ken, and Ken number 2. We do have a couple questions that came in the questions box. You can expand that open because we do have some time. First question, I can read this. What lessons learned from previous VA Joint Legacy Viewer JLV work can BPM Plus leverage to improve the HIMSS definition of interoperability? Is the Perspecta Health Concours platform open source? How much mapping did you have to do for the host EHR to ingest the data in a FHIR compliant format? Sorry, there's 3 questions in one, but if you guys can see that was our first question.
Shane, you want to take the first one and I'll take the other ones?
Yeah, let me start there. I'm having trouble finding who sent that, but I'm assuming it's Rachel out there. I hope it is. We can learn a lot from interoperability efforts that we've done between the VA and DoD and really across the industry. Lots of different ways to look at interoperability. I was taught years ago by Ken that when you look at not just healthcare, but other process and information rich industries, there's really 3 layers of it. There's data flowing, so the syntactic or technical interoperability, the ability then to have some semantic interoperability or data with meaning. Bo showed us a lot of that, and I know in JLV we do some of that now there too. But the deal with all of that is when we look at healthcare, data is just what happened before now for the patient, right? The only things that we can affect are the things that happen after now, making sure that the processes that people flow down, that the right things get done, that things don't get missed, that when people become a high risk in the future, that they're identified and dealt with. Those extensions, right, and what we're seeing from Health Concours, both from the really across the pyramid of interoperability, from data to semantic understanding, but then applying it at the level of process interoperability allows us to start to impact the future of the patient with best practices as well. So I'm assuming it was Rachel who asked that question. If not, this builds and extends on the work that has been done by applications such as the Joint Legacy Viewer in the past.
Great, thanks, Shane. And the other questions were around open source and mapping. So is Health Concours platform open source? So Health Concours is not a single thing, if you will. It's a system of systems, as is sort of alluded to by this slide with the company logos on top of it. And so there are certainly key aspects of this that are open source. For instance, for the data orchestration, we use open source libraries like NiFi and Kafka, which are pretty powerful tools that are available in the open source community. But in some cases, we use non-open source solutions. For instance, the Wolters Kluwer is one of the industry leading companies around terminology, and they have their health language engine, and that is not open source. So it's really a mix of COTS, bespoke, and open source solutions. And we believe that's the right answer, right? We believe that heterogeneity is not going away. You need to find a way to address that and have platforms that provide cohesion to a variety of technologies, regardless of how they came to be, where they came from, or whether or not they're open source or not. And then the second question was the level of effort, I think, around mapping from host EHRs to the data in a FHIR compliant format. So there's really 2 parts to that question. First, you can sort of use the 80-20 rule to get a lot of the data mapping. So a lot of data can come through HL7 version 2 messages or CDA documents or other sort of previous versions of FHIR or other sort of predictable formats like comma delimited type formats, in which case you can build general mappers. And we work a lot with Ken and his company MDIX to do mappings of those HL7 v2 to FHIR maps, for instance, and that's reusable. So I say 80-20 because we built a 20% that solves 80% of the use cases. The remainder of that, though, is oftentimes proprietary custom mappings, where you have to have intimate knowledge of, for instance, Cerner's Millennium objects or M pages, or Epic's proprietary APIs, or whatever the case may be, and that obviously requires a little more effort. And there are libraries out there and companies who manage those types of processes, who know how to work natively with those APIs, and those companies are partners of ours. So we'll bring those companies in where we need to do that last layer of mapping. So hopefully that answered the question. Should I keep going on the question list, or
yeah,
no, go ahead?
Sure. Yeah, you have access to that? Yeah, question 2. How much reconciliation did Perspecta Concours do to avoid having the clinician having to navigate for clinically contextual context?
Much reconciliation. I'm not sure. Shane, do you understand the question? I'm not sure I do.
I don't actually. I mean, I could answer what I think it means, but I don't. Whoever typed that, if you wouldn't mind throwing it back in and just clarifying what you mean by that, and we'll come back to it.
Okay. And Bo, go ahead if you want to hop to the next one.
Sure. Okay. Okay. Thank you. So there's a question: how do you handle the absence of data or inability to find the data that you need in FHIR to drive through your model? So you might recall there was one step where I actually showed exactly this, where the model wanted to make a decision, and that decision had an algorithm behind it, and that algorithm required a set of data, and we didn't have all the data, right? It wasn't in the patient's chart, or maybe it was, but it wasn't mapped to FHIR, or whatever the case may be. In which case the behavior was to raise awareness of the fact we don't have it, and then let the UI decide what to do, right? In our case, for our demo, our UI generated a form dynamically that allowed the human on the other end to input the data through structured data capture. It wasn't free text, right? It was a drop-down list where you can indicate what the status of a particular condition was. So you could supply the data that was missing to then finish the automation step that was behind that. So that's how we have solved that problem. Okay, let's see. Does the group think we'll ever slay the sacred cows and get a health concourse available in the private sector too? Certainly, we believe this is Health IT 2.0, right? Health IT 1.0 was EMRs and the digitization of patient records, which occurred 10 years ago and got us, to having electronic data. But that data is not standardized, it's not computable, it's not shareable, all the problems that we discussed earlier. 2.0 is a platform, right? 2.0 is the platform that's standards-based, it recognizes the ecosystem, it aims to provide cohesion, it embraces heterogeneity, and allows you to plug and play your EMRs, your knowledge systems, your analytics, whatever it is, in a meaningful way. And our vision is absolutely that these platforms become available to organizations that need them, whether it be in the private or public sector.
Go ahead. Get a question from Arnaud here. Thank you for the kudos in the presentation. Really key question here is, how is it received by doctors, and I'll say other healthcare providers, when decisions are automated? Specifically, do we ask for manual overrides and things along those lines? Critically important question. I would encourage you actually to join. We're going to have 2 webinars on this tomorrow. We'll go into a little bit more depth there on these, but there are two pieces in automation I think that are most important for healthcare to address this. Is number one is the manual override thing. Is the big red button on the conveyor belt that stops things and can stop whatever processes there are to make sure that whatever the process is, if it isn't right or if it isn't working for the clinician or the patient, can be stopped immediately. The second piece is for the majority of the implementations, it's really important to bring it up to a level of verification and validation by a human being at this point. Meaning, if there are clinical decisions that need to be made, if there are risk levels that can be adjusted or understood, to bring it out with an intervening task step that it brings it to a human being with inside of a highly usable interface
that allows them to verify, validate, and or change any of that information. We did not build a lot of those into what you saw here today because we were working straight from the CKD pocket card, but it really is a critical step for the human operator in this human computer interface to have a moment in there to, prior to moving things forward, to understanding, validating, and verifying. When it comes from a regulatory perspective, this is health IT, these aren't medical devices. So it's a totally different set of criteria in that regard. Hopefully that answers your questions.
Awesome. And I think we have time for one more question.
Okay, I'm looking through the questions. There's lots of good ones here.
And we'll capture them all, promise.
I mean, I guess we'll go ahead. I'll just go to the next one on the list. What's the applicability of this platform outside the U.S. where the health IT market is more fragmented and the standards are less adopted? Yeah, I think that's a great question. There's nothing. Well, so let me back up. This is a FHIR-based architecture because FHIR was a standard of convenience in a sense. It allowed us to have a single canonical representation of data that made it computable such that we could run it against clinical decision support algorithms and automate it through business process model diagrams. If FHIR was not adopted, the architecture itself, we don't store the data with our own proprietary data model. We store it as the objectified representation of whatever canonical format we're using. So if it's not FHIR, we could use something else. We could use the NEAM or a CDA type structure or something else if FHIR wasn't available as sort of the basis for that. And we would have to modify, some of the logic in the APIs, but you wouldn't have to throw away the entirety of the system. It's meant to work with, a canonical format, whatever that format may be. So that's maybe a bit of an abstract answer, but you have to have something as a common denominator for these things to come together and provide cohesion. For us right now, it's FHIR, CDS hooks, and BPM plus.
Well, could I just extend on that a little bit? I think that's
Sure.
just, if you took sort of what's in Europe and maybe it's an open air sort of instantiation of the thing, that would, in a way, would just represent another different PISM that actually uses a different type of representation than FHIR. So I think sort of the BPM plus community has tried to be able to implement into, whether it's a proprietary one, whether it's a different standard, everybody, for very good reasons, FHIR has significant benefits, but from an architectural view, it can be instantiated in different PISMs.
In fact, that's a key point, Ken. And really one of the main things about operationalization, right, the steps that Ken was walking us through before, is that the platform independent model, and let me go back to this view here, the platform independent view, the diagram behind the scenes, isn't specifying that it's FHIR or open air or HL7 or CDA or any other sort of structure for the data. It's just specifying the data that's known to the business subject matter expert, right? And the operationalization step is to take that business construct, that data object, and map it to the appropriate implementation specifics of a given target platform. In the case of Health Concours, that was FHIR. If it was a different platform, it could be mapped to an open air archetype or whatever the appropriate representation should be. And that's the whole reason you have that separation of concerns, where the platform independent model can run anywhere and describes the business problem and the clinical intent, and the operationalization binds it to the platform specifics that allow that same model to run in different platforms based on different capabilities and technologies and standards.
Excellent. Thank you guys so much. Thanks for everybody that tuned in. If you're around this afternoon, we have 2 more sessions coming up. Again, the link is in the chat box to see our full schedule of events over this afternoon, tomorrow afternoon. That's Eastern time, morning if you're West Coast like Bo. But thanks again. We're going to capture the recording. We'll have this posted either later today, first thing tomorrow, also up on our site. And we'll see you again soon. Have a good rest of the day.
Thank you all.
Thanks.